Motion and time. We will explore about it. What is the motion? What are types of motion? What is the time? Okay. Each words which will be more important from this we will explore. We will explore. Here, first word as you can see is what a spell. From in your language, what will be meaning of a spirit in your language? How do you express? How do you explain a spirit word? Meaning of this word is what? It tells us. Tells us what is the spirit of something. What is the spirit of a something? For example, a spirit of it will it will give you distance that was covered by a car with with within time within time. So something was covered by time, and that will be what a spirit. Okay, by time. Distance by time. For example, 4 4 4 kilometer. It is a total distance, but how much time taken? How much time taken? You can say uh, 1 hour, 1 hour, 1 hour. Okay, not for 40. You can say in 1 hour, car covered distance of 40 kilometer, and we write it to consider a speed how 40 kilometer per hour, like that. So now we are saying that yes, this is the speed of a car which covered which that car covered how much total how much distance? 40 kilometer within 1 hour. Within 1 hour, time taken by car only is of how much? 1 hour. So it is a speed. It is a speed. In some words, you can say, you can explain a speed word. You can say it will tell what distance, total distance covered by something, and taken time by that object. This speed will take now. Okay, it will tell what total distance within a time. Total distance within a time. What about instantaneous speed? What about instantaneous speed? What do you think? This is different from the. Is this different from the speed meaning? Yes, but little. But little. This speed will tell you current speed. What is the current speed of this bike? What is the current speed? Current speed. Okay, and you will see this current speed in a speedometer. Current speed of bike will be will appear where? On a speedometer of the bike. Okay, vehicle or vehicle has what a speedometer in which driver uh, driver observes that yes, this much speed, with this much speed I am driving the car. I am driving the car with this much speed. So how driver observed with help of a speedometer, and a speedometer will tell you current speed of the car. So here, an odometer will tell you a speed, total speed within time, and it will tell you with a kilometer per hour. It will tell, this odometer will show what total distance in kilometer and time in hour. But this will tell you what current speed of the car. Current speed. A speedometer. Always remember, a speedometer tells us current speed of the car, of the of anything. And instantaneous speed, which means instantaneous. We say what instead of speed. Instead you will get result. That's why that is that is how we say sometimes. We say sometimes instantaneous. Instead you will get result like that. So here instantaneous word, in simple word it is said, simple word of the instantaneous would be current. Okay, so current speed, what is the current speed? So current speed is just instantaneous speed. So here current speed will appear on a speedometer of the vehicle, but a speed, total speed total speed will appear on odometer of the vehicle. So that is what we understood. Now next is what? Uniform motion. Uniform motion, non-uniform motion. Non-uniform motion. What is the meaning of this word and what is the meaning of this word? What's the difference between them? Both will not be equal, but there is something difference. Here, uniformation. What is uniform? What is uniform? It is clearly saying that motion will be what? Motion will be will motion will be what? Equal. Distance will be equal. Internal time. Otherwise, you can understand by this. A car is moving in straight. A car is moving in a straight road. Okay, this is car. Let's say this is car. It travels. This car travels from here to till here. How much? Let's say 20 kilometer. 20 kilometer within a I think 30 minutes. Within a 30 minutes. Okay, within a 30 minutes. Within a 30 minutes. So from here to till here, car traveled how much distance? 20 kilometer. And car took time how much to travel 20 kilometer? How much? 30 30 minutes. 30 minutes. Okay, 30 minutes from here to here. Now again from here, not from here. From here, this car traveled. This car travels how much? 20 kilometer distance here. 20 kilometer distance. Again, okay. Within a same time. Within a same time. Time is the same. 13 minutes. 13 minutes. 13 minutes. So now from here we can say this is equal to this. This is equal to this. Both are equal. Both are equal. Yes, we confidently can say. Now again this car is traveling. This car is continuing from here to till here. This car again travels with a distance of 20 kilometer. 20 kilometer within a 30 minutes. Now from this pattern you can observe what distance are equal within a 30 minutes. Within a 30 minutes. So we say time travel, this is a 30 minute, this is also 30 minute, 30 minutes, this is also time travel of the car is equal. of the car is equal. Time travel of the car is equal, and distance is also equal. This 20, this 20, this 20. Distances are also equally are also equal. So distance are equal with the interval of time, and interval of time by the car is equally. Then we can say that motion of the car is uniform motion. That motion of the car is uniform motion because time travel is equal, and the distances are also equal. That's why. Now next, after 30 minutes or after 30 minutes, it also travels 20 kilometer within a same time. Again, same distance, same time. So car is moving what? With a constant distance, with a constant time, with a constant time. So can we say motion of the car is constant. Okay. Uh, a speed is a fixed. A speed of the car is a fixed. A speed of the car is fixed, and motion of the car is constant because of there is no acceleration. There is no acceleration. We will talk about acceleration later. But here, car distance of the car, minutes of the car is fixed. That's why we are considering it as a constant motion because distances are fixed, times are fixed. That's why time is fixed. So we can say constant motion, constant motion. Next what? Equal interval time, equal interval time, and next equal distance after interval time, equal distance. That's why after looking this, we are saying that motion of the car is a constant motion. In this case, non-uniform motion. What happens in that case? What will happen? Here, car travels from your 20 kilometer, but within what? Within 25 minutes. Within 25 minutes. Now, again here, it travels how much? 26 kilometer within 35 minutes. From here to till here, car traveled distance of 20 kilometer within 13 minutes, and again from here to till here, car traveled distance with a distance of 20 kilometer. But time is a different. Time taken by the car is 25 minutes. So this is a different from the previous time that was taken by the car. Now from here to till here, car traveled with a distance of 26 kilometer, and time taken by the car is how much? 35 kilometer. It is also time. Now time which was taken by the car is also different from the previous time. So it doesn't matter. Look, time travel, there are changes about time travel. There is a no fixed time. There is a no fixed time. There is a differences in time travel, and distance of the car is the same. Then we can say this is a motion of that car is a uniform motion. If distances are changing after equal interval time, then again we can say motion of that car is a uniform motion because of there is a no constant motion. There is a no equal distance after fixed time. Okay, after fixed time. Are you understanding? Here there are any changes after after time there are any changes mm, in distance with a distance of a car. So here, from here, you will understand, you will observe what acceleration, deceleration. Again, I would like to say we will discuss about acceleration, deceleration later. But here, we are, we will be able to observe when we will have a understanding of acceleration, deceleration. Then you can say confidently that yeah, in this in the case of non-uniform motion, there is a acceleration, there is a deceleration. Uh, for example, from here to till here, travel distance is a constant from here to till here. Uh, Traveled by car is a constant, but time is not constant. Time is not constant. Interval time is not constant. Interval time is not fixed. That's why. That's why this type of motion will be considered as a non-uniform motion. So here, non-constant, constant motion, non-constant motion. This is first. Second is it can be equal. It can be equal interval time, but not a equal distance time. It can be equal distance time, but not a equal interval time. Interval time. Okay. That is how you will determine any information as a any motion as a uniform motion as a non-uniform motion. That is how you will see what both two things. First, is there any constant motion? Is there any equal time travel with equal distance? That is how you will determine. From this concept, we understood what is a uniform motion, what is the meaning of a non-uniform motion. Now, let's draw a figure in which will in which there will be distance time graph. We are going to draw a graph in which from which we will understand motion. Through graph we can understand what is the motion of a something through graph. So let me draw a graph. Distance, we will call it as a distance a time graph. Time graph. Graph in which is what distance time. this timeline is of a time, and this timeline is of a distance in kilometer, and this is the time in minute. Now from here you will understand very interesting points. Let's understand, let's explore. From these two graphs you can observe what two types of motion. This timeline is telling what time of this line. Here let's say there is a one thing we are plotting a. Let's say here is a what? Here is a car, you can say. If a car is here, then we can say from here to till here car came, and now car took how much time? Vehicle, I would say vehicle, okay, vehicle took time how much? 10 minutes. From 0 to till here. So from here there is a vehicle, okay, I will call it as a V. I will represent it as a V. Which means V stands for vehicle, okay. So vehicle is here, from here to till here. So this vehicle took 10 minutes and it covered how much? 5 kilometer distance within a 10 minutes. This is what is the meaning of this graph. Okay, from here you can interact with this graph. Vehicle is here, so it is telling that this vehicle took 10 minutes, but it also covered 5 kilometer distance. Okay, no problem. Now what if vehicle is here? Then what is? Now I want to ask you, what is the distance of this vehicle and time? How much time this vehicle took and how much distance this vehicle covered? You would say here. See here. This is a time. So here this vehicle took 20 minutes time, and it covered how much distance? 10 minutes time. How much distance? 10 minutes time within a 20 minutes. Okay. Now vehicle is here. It took 13 minutes time. It took 13, not 13, 30. This vehicle took 30 minute time, and it traveled 15 kilometer distance. Within a 13 minute. Okay, this is all. It will keep going on. Now try to understand. From this pattern you can observe what? Equal distance, equal time travel, because of this line is in a state. That's why it is forming a uniform motion, because of line is straight, but it is not in horizontal. If it will be horizontal, then there will be constant. Yes. So here equal distance you can observe time 10 minutes. Then here again, so this is a interval time. This is a interval time. How would you say this? From here to till here, how much time? 10 minutes. Again here, from here to till here, 10 minutes. From here to till here, 10 minutes. From here to till here, 10 minutes. So time travel. No. Interval time is equal. So interval time is how much? 10 minutes. Now distance would be also equal. Distance would be also equal. You can see from here is how much 5, and again from here is how much 5, from here again 5. So 5 is what? So here distances are equally. Distances are equal. So interval time is equal, distances are equal, distances are equal. Okay. Okay. Now what else? What else? Now we are able to consider it as a what type of motion? Now we can say this is a motion of a uniform motion. Uniform motion. It is a constant motion. Okay, it is a constant motion. In this graph, you can see within 10 minutes, within a 10 minutes, this vehicle traveled how much distance? Let's say 4. Okay, 4. Again here within a 20 minutes, 4 kilometer. Okay, this is minute. Within a 20 minutes, this vehicle covered with a distance of let's say 6 kilometer. 6 kilometer. One more, let's say this is a 30. Within a 30 minute, this vehicle traveled a 10 kilometer. Now see, time travel is equal. Okay, time travel is equal. No, not a time travel. Interval time is equal of this vehicle, but the distance is not equal. From here till here is a 4 kilometer, but from here to till here is how much? 6 kilometer. How much? 6 kilometer. So 6 minus 4 would be 2. 10 minus 6 would be 4. So distances are not equal. But here you can see 10 minus 0 would be 10. 20 minus 10 would be 10. 30 minus 20 would be 10. So here this time travel is equal. So not a time travel. Interval time is equal, and interval time is 10. But here you can see interval time is a different. Interval time is a coming different. Here 2 kilometer, here 4 kilometer. So they are unequal interval time. Okay. So if there are any changes in distance with time, then we will consider that motion as a uniform motion. Okay. And now you can see this is not in straight. It is a curved line. We will not call it as a constant motion. It will be considered as a unconstant motion. So that is what we have to understand. Now one thing more here. Can you tell me what type of motion is there? So here within a 10 minutes, it is covering how much? It is covering 5 not 5, 20, 20 20 kilometer distance. This vehicle is traveling with a distance. This vehicle traveled with a distance of 25 kilometer within a 10 minutes. Again, within a 10 minutes, it had traveled how much? 25. Again, within a 30 minutes, it had traveled 25 kilometer distance. We can say this is in rest. This is in rest. There is a no any motion. There is a no any motion. After there is a no any motion. Yes. Because of time is a changing. Time is a passing. But vehicle is not moving. Time is a passing, but vehicle is not moving. Anything is not moving. How can we say that that object is in motion? No. Until that object will move, we cannot say that that object is in motion. If that object in rest, then we would say yes, that object in rest. So here, this graph is showing that something is in rest, not in motion. Okay, time is passing, but object is not moving. Now let's accept some question. Some question. Now this is question. This is first question based on this. Which physical quantity will determine the fastness or slowness of an object? Can you say that the distance determines the fastness or slowness of an object? It determines total distance. It determines total distance by covered by an object. But it will not determine a speed. It will not determine fastness or slowness. Time, it will also not determine fastness or slowness. Yes, it can tell. Time can tell that something is moving within this time, and we are able to say that yes, within a time. So this object is moving very fast. So we are able to consider because of a time. But work of this is not determine the fastness or slowness of an object. Here a speed. I think it would be answer for this question, but displacement no. It is a shortest path. It is a shortest distance of an object. It is a shortest distance. Now let's explore a little a little bit of a speed. It will tell, yes, it will tell, and it will appear. It appears where? On speedometer of the vehicle. This is uh, this is what determines the fastness or slowness of an object. A vehicle is moving fast or slow, who will tell? A speed, and a speed will appear on a speedometer. A speed can be observed from a speedometer by driver, by a rider, you can say, by a driver. This speed will tell that yes, so uh, vehicle is moving with this kilometer by this time. So this will a speed tells fastness, about the fastness or slowness of an object. So this would be answer. Now one point is clear. Work of a speed is to tell. Work of a speed is to tell what is a fast. What is a It tells what fast movement or slow movement of an object. So this will tell. Next question with the air diagram. We have this figure. We have this figure by this question. There will be twist. There will be twist. How? Just say here. Which one among A, B, C, D? This is a car. This is B car. This is C vehicle. This is a D vehicle. Which one among this car will be fast? Will be fastest? Fast car. Will be fast car. Will be fast car. You know this is vertical. This is horizontal. Here, I want to ask you. You answer this question. This car is moving. A vehicle is moving. So it is taking how much time? Let's say 5. This is again 10. This is again 15. This is again 20. Let's say okay. Here we have to tell which one car is moving very fast. Is moving very fast. And if this A vehicle A traveled, let's say this is a 30 kilometer, okay, 30 kilometer. This vehicle A traveled with a distance of 13 kilometer within a 5 minute. Within a 5 minute. within a 5 minutes. And vehicle B traveled how much distance? Uh, Covered how much distance? 13 kilometers, but within a 10 minutes. Within a 10 minutes. Vehicle C covered vehicle C covered 30 kilometers again, but within a 15 minutes. Vehicle D covered again 30 kilometer within a 20 minutes. Now, so here a vehicle is covering same distance, okay, same distance, 13, 13, 13, 13. But time, time is a changing. This first A vehicle covered 13 kilometer within a 5 minutes, but you can see this vehicle D is covering same distance, but it is taking more time. This vehicle A is taking less time compared to vehicle D. It is taking more time. So which one vehicle is taking less time to cover this same distance? To cover the same distance. So answer would be finally vehicle A is covering the same distance but within a less time, within a 5 minutes. So of course final answer would be A. Final answer would be A. That is how you will answer. Here this was a twist. Many of you can get confused, but you have to answer logically. Here logic word will come into picture. Now next which is based on motion, we have this complete question. There will be also test. There will be also test. Here from this question you can get confused, but take time, but give answer logically. Okay, that is what I want. So answer would be what? The motion of the pendulum bomb is pendulum bomb of a clock watch. Okay, the motion of the pendulum bomb of a wall clock watch is what? So of course motion of the pendulum would not be circular. Circular looks like this. Circular motion look like this. Something is there and it will move like this. But pendulum of the wall clock watch does not move in like that direction, in this direction, in circular motion. Okay, periodic motion, periodic motion. It is saying that it will take interval time. It will take interval time. Okay, let's just say this is object. It will go like that, and then it will repeat. It will repeat again. So this is what periodic motion. But it happens also in with it happens with also with a what a pendulum, with a pendulum of a wall clock. It also happens. But we cannot say this will be answer for this question, because circular motion pendulum does not do circular motion. That's why rectilinear. No, 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 no. Pendulum. Otherwise, we can say pendulum would motion how this will be like that. So we can say periodic motion. Okay, because reason is that it is a taking same time. It is a taking same time after completing a periodic motion, a motion. Okay, from here to till here, after completing from here to till here distance, it is a repeating again and again with time, with the same time, with a time. So that's why we are saying it will be considered as a periodic motion. Next what else? Oscillatory motion. Can we say oscillatory motion? Oscillatory motion. Oscillatory motion. Meaning of oscillatory motion what? To and fro, to and fro, to and fro, to and fro. It will go like that, then it will go like that. Okay, so yes, this motion will be oscillating motion. It start from here, then it will go here, then it will come back, then it will go backward, then it will come here, then it will go here, then it will come back. This is how oscillatory motion is determined. So pendulum motion would be what? Periodic motion, oscillatory motion. So here this also will not be answer for this question. Yes, D is the answer for this question. Motion of the pendulum is oscillatory and periodic motion. Clear? This was answer. This was answer. Rectilinear, which means what? Rectilinear, which means objects are moving in same direction. In same direction. This is motion which is considered as a rectilinear. Okay, circular, which do motion in circle shape, in like a circle shape, like that. Okay. Now next we have a statement. We have statements. Now you have to tell which one is the correct, which one sentence is correct, or both statements are correct or not. If yes, then why? You have to tell reason. You have to give reason. Statement one is saying the shadow of an object during the day. Shadow object can be home, object can be anything. There are a lot of objects which are surrounding us, which are present surrounding us. So during the day, who will determine shadow of an object during the day? Sun. Sun will determine. Sun, if sun is this direction, then shadow of an object will be this. Let's say I am here and sun is this direction, then shadow will be here. Shadow will be this direction. If sun is in front of me, then shadow of me will be behind me. So who are taking decision to draw my shadow? So sun. Here, the shadow of an object during the day can be used to predict the time. Yes, yes, yes. We say okay. If if sun is above me, if a sun is above me, so there will not be any shadow, but a little bit. So it is happening because of a time. We can predict the time by by looking shadow of an object. We can predict, but we cannot say exact time. But yeah, almost we can predict the time by shadow of an object during the day. So here statement one is correct. Yeah, even we do predict sometimes. When person does not have a watch, then they predict the time. How? By looking sun, by looking what environmental. Okay, sometimes weather is what bad, weather is not good sometimes. So we get confused what will be time now, right now, but we are able to predict the time. So by the shadow of an object. So a statement two is saying periodic motion of an object can be periodic motion of objects can be used for measuring the time. Yes, yes, yes. For measuring the time, both are correct. Periodic motion of an object. Periodic motion of an object can be used for measuring the time. Yes, it will happen. It can be observed with the pendulum of a clockwise. Yes, yes, it is also correct. This is also correct. Next question I would like to take. This was two statements. Next is a very interesting question. You will get confused, but don't worry, I am here with you. I am with you. So here next question is this is a pendulum of something, of a something. So here, answer, what would be answer? Here this is pendulum. Let's read this question. If the time taken by the bow of a pendulum, this is a bow. Okay, this is a bow. Okay. Time taken by the bow of a pendulum to move from point O to A is how much? From here to till here is a it is a taking, this bomb is a taking how much time? 4 seconds. 4 seconds. Okay, 4 seconds. Then the time taken by it to complete its one oscillation from here to till here, how much it will take time to complete only one oscillation? Total time we will have to, or we will have to tell, we will have to tell. If from here to till here is how much? 4 seconds, then how much will it take a time to complete a one oscillation? Okay, so if from here to till here is a 4 second, okay, 4 second, it will come again here, again 4 second, it will go here, so again 4 second, then again it will come here, again 4 second, from here to till here 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 it will come here, of course 4 second. We started from here and we are ending here, so of course now it is a complete one oscillation. Now we will sum all this. 4 4 8 8 8 16, so answer would be 16. We are starting from here and we will end same here. Okay, so from here to till here 4 second. Okay, from here to till here how much? 4 second. Okay, from here to till here how much? 4 second. Okay, now it will come here, so we can say confidently that it is a complete one oscillation. After adding all this together will give us how much seconds? 16 seconds. So to complete one oscillation, it is a taking 16 seconds. It is a taking 16 seconds. That is how you will answer. That is how you will answer. Just have a look. Now, next question. No. Which one is correct? Let's say you have three statements. Here, first is saying the basic unit of a time is how much? Is what? Second. This is a unit of a time. Yes, it is a universal truth that unit of a time is a second. It will be always a truth. So this is a correct. One is a correct. Second, distance between two cities is measured in kilometer. It is also true. I want to know from here to till here is a how much. Let's say this is a one building and this is a next building. This is a other another building. These two buildings are in one area. I want to know what is the distance between them. So we will measure it in kilometer. So yes, it is a true. To find out measurement of two cities, we find what in kilometers. The speed of a train is expressed in meter. In meter, not. And the speed of a train will be expressed in kilometer by hour. Okay, so it is not a truth. This is a universal truth. This is universal truth. That's all from this is right.